Okay, so conservation of momentum then. It says here, by Newton's third law, when two bodies collide, each one exerts an equal and opposite force on the other. They are in contact at the same time, so they each exert an impulse on the other of equal magnitude but in opposite directions. By the impulse momentum principle, the changes in momentum of each body are equal but opposite in direction. Thus, these changes in momentum cancel each other out, and the momentum of the whole system is unchanged. This is called the principle of conservation of momentum. Next wee bit's the important sentence here. So total momentum before impact equals total momentum after impact. That's going to be the equation we'll be using to work out most of these. You can write these symbols for two masses m1 and m2 and velocities u1 and u2 respectively before the collision, and the velocities v1 and v2 respectively after the collision. m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. It's a bit like, in the way I tend to think about it, it's kind of two snooker balls kind of coming together and hitting each other whenever they hit each other. So momentum before, there's the first ball, momentum of the second ball before, and then they head off in different directions, and that's the momentum afterwards. When solving the problems, always draw a diagram, show the velocities before and after the collision with arrows. If appropriate, include the impulses in your diagram with arrows, and then choose a positive direction and apply the impulse momentum principle and or the principle of conservation of momentum. Let's take a wee look at our first example. Oh, taking off the wrong page. I hope you can read that okay. So a particle P of mass 2 kilograms is moving with speed 3 meters per second on a smooth horizontal plane. Particle Q of mass 3 kilograms is at rest on the plane. Particle P collides with particle Q, and after collision, Q moves off with a speed of 7/3. Find the speed and direction of P after the collision. With all of these, we need to learn that you have to draw a before and after diagram. So this is what's going on before. We have two particles. We normally draw them like this. P and Q, they're supposed to be the same size, it's just my bad drawings. That's 2 kilograms, and this one is 3 kilograms. This one is moving with speed 3 meters per second, and this one is at rest. After collision, so they hit each other and then they head off in a certain direction. We're not quite sure what direction they kind of head off. After, we're told that this one goes at 7/3. Sorry, I should write it after up here. And it is 3 kilograms, obviously. This is our P, this is our Q, and our 2 kilograms, then we don't know what way it's going on, but that's what we've been asked to find out. So we're going to call that V. We set up our equation then. M1U1 plus M2U2, as in momentum of this one, momentum of this one, so this is both before, equals M1V1 plus M2V2. I pick a direction to be positive. I think it's reasonably obvious to take this way here as positive, because that's my 3, and that's the direction it was going at the start. If I move up slightly, we'll hopefully get this. So mass times velocity, so that's 2 times 3 plus 3 times 0 equals 2 times V plus 3 times 7/3. What do we have on this side? We have 6. Just move this down a bit. Try and keep so we can see this. 6 equals 2V plus 7 minus 1 equals 2V, and so minus a half then equals V. So what have we worked out? We've worked out that V, the speed then of this second one, is actually minus a half, so it actually ends up going this direction here. Because the minus came out with real, and we were taking this way to be positive, it must then be going this way. So let's see what we have. Therefore, P moves with 0.5 meters per second in the direction, can't spell direction, opposite to its original motion. And again, the examiner would want to see something like that. They want to see that we know which direction it's going and define that then at the end. Part B says the magnitude of the impulse received by P in the collision. So we're only dealing with P here. So impulse is change in momentum. So I equals 2 times minus a half, because that's the speed it was going after, obviously, minus 2 times 3. I equals minus 1 minus 6 equals minus 7 Newton seconds. Therefore, magnitude, and it asks us for magnitude, of impulse is 7 Newton seconds.